Today's daily code problem of the day is count hills and valleys in an array number 2210. For this problem, we're given a zero index integer array called nums, and an index I is part of a hill in nums if the closest non-equal neighbors of I are smaller than it, and similarly if index I is part of a valley if the closest non-equal neighbors are larger than it. So for this problem, we need to analyze if a number is a hill or a valley by analyzing the two numbers adjacent to it that are not the same number. So in this example, we have 1 and then 1. You would think, okay, this can't be a valley because it's flat on the other side. Well, in this scenario, we would look at 1, 4 as its left number, and then 6 as its right number, because we're not going to look at duplicates. Pretty sure in the discussion I saw, yeah, here we go. So this is kind of how we're going to be looking at it. So even if there are duplicates in our valleys and our hills, we will actually look at it as if there is no duplicates. So our simple solution is going to be ignoring the duplicates in the hills and valleys and simply calculating their total. So we want to return the total of both hills and valleys. So we'll keep them all in one counter and we'll call that our result and initiate it as 0. Then we're going to use a sliding window technique. So we're going to keep track of what's to the left of our number and what's to the right of our number. And this is because no matter what, as long as we have the left pointer, we don't need to worry about if the right pointer has something duplicated next to it. For example, if we're looking at 1 here, the right value is a duplicate, but the left value isn't. So left will be 4. Well, we'll look at this one, and then we'll look at what's to the right of it. It's a duplicate. Okay, so we'll skip that one. Now we'll look at this one. Okay, well, what's to the left of it? Our left pointer is still on 4, and then our right pointer will be looking at 6. So that way we know that there is a valley here. We didn't need to do any operations getting rid of a 1, and we don't need 3 pointers, one for the middle, one for the right, one for the left. We just need 2 pointers, and so that's how we're going to solve it. We'll initialize our left pointer as int L is equal to 0, and that is our left pointer. Now we're going to have our for loop, which is going to be our middle pointer, and we'll look at what's to the right of it. And because it is impossible for our left or our right value to have a right or a left hill or valley, we are going to skip those last values. We can initialize I is equal to 1, and as long as I is less than nums.length minus 1, I can increment. So that's it for our for loop. And now all we simply have to check is if the number to the right of our number is equal to it. If so, we don't need to look at anything else. We'll skip it and move on. So if our nums of I is not equal to our nums of I plus 1, then we can do further checks. Otherwise, we're going to skip and we'll move on. So in this example again, if 1 is equal to 1, then we're going to skip this first one. We'll move on to the second one. Our left pointer won't move, and our right pointer will be on a new value. So that's all we got to do. Nums of I is not equal to nums of I plus 1. Then we're going to check, is it a hill or a valley? So if our nums of I is greater than our nums of L and our nums of I is greater than our nums of I plus 1, well, then we have a hill because our nums of I is greater than its left and right value. Otherwise, our other case is if our nums of I is less than our nums of L and our nums of I is less than our nums of I plus 1. So those are our two case scenarios. And for these, we can simply increment our result. So those are the only two possibilities. We'll increment our result if either of them are true. So after we increment our result, we now need to increment our left value because we've already used that left value. And we know that there are no hills or valleys between the left value and our current I value. So we'll then increment our left value to be equal to I. So L will now be equal to I will increment forward, and we'll check again. And that's it. We can return our result. This passes our test cases and passes all solutions. So thank you, and follow for more data LeetCode solutions.